students, let us see the new type which is linear upon quadratic. Let us see the general form of this type. It is px plus q upon ax square plus bx plus c, or it can be of the type px plus q upon root of ax square plus bx plus c, or px plus q into root of ax square plus bx plus c. That is, we are discussing actually three standard forms: linear upon quadratic, linear upon root quadratic, or linear into root quadratic. My dear students, all of them have the same method. And what does the method require us to do? It says that the very first step is express the numerator, which is px plus q, as a into derivative of ax square plus bx plus c plus a constant b. Our job is to find the values of a and b and then evaluate the integral. How? Just check. The next step says find the values of a and b by comparing the coefficients of x and the constant term. That we will see with an example. And after that, we are just supposed to separate the numerator and evaluate the second integral by using the perfect square method. Now, what all these steps mean and how we are actually supposed to use, let us see using an example. Question says integral of 2x plus 3 upon 2x square plus 3x minus 1 dx. So let us see the very first step. It says let the numerator, so let 2x plus 3 is equal to a times d by dx of 2x square plus 3x minus 1 plus b. So now my dear students, what is derivative of 2x square plus 3x minus 1? It's 4x plus 3. So let us write here plus b has to be as it is. Now if I write the next step, I can say 2x plus 3 is equal to, open the brackets, we get 4a into x plus 3a plus b. Now my dear students, we are supposed to find the values of a and b, and for that we compare. Comparing the coefficients of x and constant on both sides, we can say that 4a is equal to 2. Right now I am comparing the coefficient of x, so 4a is 2. So can we say a is 1 by 2? Likewise 3a plus b is 3. So can we say 3 into 1 by 2 plus b is 3, or b is 3 by 2? Correct? So we can say 2x plus 3, which was written as a times 4x plus 3. That's half of 4x plus 3 plus b. So plus 3 by 2. This is what we have done. And why we have done? Because our integral has the numerator 2x plus 3. Now instead of 2x plus 3 in the integral, we will be writing half of 4x plus 3 plus 3 by 2 upon the denominator will remain as it is, 2x square plus 3x minus 1. Obviously dx has to be there. Now my dear students, what we are supposed to do? After this we are supposed to separate. The step 3 is separate. So you will find this red dotted line here. So we will write in the next step half of integral of 4x plus 3 upon 2x square plus 3x minus 1 dx plus 3 by 2 integral of 1 upon 2x square plus 3x minus 1 dx. Now my dear students, if you observe in the first integral, the derivative of the denominator is present, or I can say it is of the form f dash x upon f of x. So answer will be log mod of f of x plus 3 by 2 I1. We will evaluate this separately. Now my dear students, let's see what is I1 equal to. I1 is 1 upon 2x square plus 3x minus 1 dx. Now you are very sure of solving this particular sum. To solve this particular sum, the very first step is making coefficient of x square as 1, and that can be done by taking 2 common. So 1 by 2 integral of 1 upon x square plus 3 by 2x minus 1 by 2 dx. Now my dear students, the next step is also known to us. Make this into a perfect square by adding, subtracting a number. So let me write this as it is, leaving those blanks, and let us fill the blanks. To fill the blanks, we require the magical number, which is half into 3 by 2 the whole square in this case, which is nothing but 9 by 16. So let's add, subtract 9 by 16. So in the next step, now what I need to do is write this as a square of some quantity, which is half integral 1 upon x plus 3 by 4 the whole square minus of, now minus 9 by 16 minus half, let's simplify separately. Can I say it's minus 9 minus 8 upon 16? That's minus of 17 by 16, or minus separate root of 17 by 4 the whole square. Dx has to be there. Now my dear students, this is of the form x square minus a square, 1 upon x square minus a square. So 1 upon 2a, so 1 upon 2 into root of 17 by 4 log mod of x minus a, so x plus 3 by 4 minus of root 17 by 4 and x plus 3 by 4 plus of root 17 by 4, obviously a plus c2. Now my dear students, here we can see that 2, 2 and 4 will get cancelled. So we will get in the next step 1 upon root 17 and inside the log we will take LCM. So log mod of 4x plus 3 minus root 17 upon 4x plus 3 plus root 17 plus c2. Now we have found out what is I1. We already know the integral. It is half log mod of 2x square plus 3x minus 1 plus 3 by 2 I1. So I just need to substitute this value of I1 there. So half log of 2x square plus 3x minus 1 plus 3 by 2 root 17 log mod of 4x plus 3 minus root 17 upon 4x plus 3 plus root 17 plus c, where c is nothing but c1 plus c2. And that's your final answer. Now, you may try these questions for practice. They are based on the same lines. That's all we have in this module. Thank you very much.